Okay, so here are the answers to our warm-up. On this first one, you can see that it does factor. It's already set equal to 0, so we factored it, set both parts equal to 0, and we get x equals 8, and x equals negative 1/6. On this one, when we set it equal to 0, we see that there's nothing that multiplies to give us negative 32 and adds to give us 7. So we cannot factor it, which means we have to use the quadratic formula, which we learned right before Thanksgiving break. So this one winds up being negative 7 plus or minus the square root of 177 over 16. This doesn't break down any further, so we're going to look at the next one. Number 3, when I set it equal to 0, I ask myself what multiplies to give me 9 and adds to give me 6, positive 3 and positive 3. Since these are the same, I don't need to solve them both. I just solve one and I get x equals negative 3. This has only two problems. I look for my GCF, which is 2x, and that factors out into 4x minus 1. Set each piece equal to 0, and I get x equals 0, or x equals 1/4, or 0.25. Okay, let's take a minute and you can check your homework. All right. Back before Thanksgiving break, we talked about application of quadratics, and we had this equation, negative 16t squared plus v sub 0t plus h sub 0. And the problems that we did then factored, and so we could solve. The problems that we're going to do now will not factor, but we could still solve because we have the quadratic formula. For example, a ball is dropped at 32 feet per second from a 45-foot tall platform. The equation for the object's height at h at time t seconds after launch is negative 16t squared plus 32t plus 45. When does the object reach its maximum height, and what is its maximum height? Okay, so what are we talking about when we ask about reaching its maximum height? Turn to your side partner and talk to him what you know about maximum height. Where does that occur? Right, the maximum height occurs at the vertex. So we get that t equals negative b over 2a. Well, b is 32, so negative b is negative 32 over 2a, so 2 times negative 16. That ends up being negative 32 over negative 32, which ends up being 1 second. When does it reach its maximum height? At 1 second. This isn't any different than what we did before. What is that maximum height? Well, what do we have to do with that 1 second? We have to plug it into here and see what our answer is. So our height after 1 second is negative 16 times 1 squared plus 32 times 1 plus 45. This becomes negative 16 plus 32 plus 45. Negative 16 plus 32 plus 45 is 61. So what is its height after 1 second? It is 61 feet high. And that's our answer for that. So if we're finding the vertex maximum height, it's not any different than what we've been doing before. Let's take a look at this one though. An object is launched at 19.6 meters per second from a 60-meter tall platform. The equation for the object's height h at time t seconds after launch is negative 4.9t squared plus 19.6t plus 60. When does the object hit the ground? Well, if the object is hitting the ground, what do we know? We know the height. We know the height has to be 0, so we set this equation equal to 0. Negative 4.9t squared plus 19.6t plus 60 is 0. Now, in the past, what we've done is we've looked for a GCF. 4.9 comes out of this, and it comes out of this, but if I divide 60 by 4.9, it does not factor out. I can't factor it, so my only option is to use the quadratic formula. So identify your A, your B, and your C. A is negative 4.9, B is 19.6, and C is 60. Now we're going to plug it in to the quadratic formula. Remember that quadratic formula is x equals negative b, so a negative 19.6, plus or minus the square root of b squared, 19.6 squared, minus 4 times a, a negative 4.9, times c, which is 60. All over 2 times a, which is negative 4.9. So I get negative 19.6 plus or minus the square root, 19.6 squared is 384.16. I have a minus and a minus, so it's going to be plus 4 times 60 times 4.9 ends up being 1,176 over 2 times negative 4.9, which is a negative 9.8. Okay. Now, so I end up with negative 19.6 plus or minus the square root, 384.16 plus 1,176 is 1,560.16 over negative 9.8. Now remember, this gives me two options, so we need to look at that. We're basically just going to plug into our calculator these two options. We're going to get negative 19.6 plus the square root of 1,560.16 over negative 9.8. Or we're going to have negative 19.6 minus the square root of 1,560.16 over negative 9.8. Okay, so plug this into your calculator and see what you get. Okay, so when we plug this into our calculator, make sure that you're either putting parentheses around this piece or that you're hitting equals once you get this in, and then divide this whole sum by negative 9.8. Same thing here. Put parentheses around this whole piece or hit equals after you hit this. When we do this, we get negative 2.03 seconds for this part, or 6.03 seconds for this part. This is our only answer because we cannot have negative time. So we want to know, when does the object hit the ground? It hits the ground at 6.03 seconds after it left. All right, so for tomorrow, you have a worksheet that's going to practice some more quadratic word problems. Again, it's just like we've been doing before Thanksgiving break. If it's asking for maximum height, what are you looking for? If it's asking for when it hits the ground, what are you looking for? If it wants to know when it's a specific height, what do you do? Work on this. Remember, you have a PC tomorrow.